finding a volume of a solid, but we're not rotating it about an axis. In other words, we're going to be given some known cross-section. Would that cross-section be, let's say it was in the form of, oh, I'm not going to go hard. I know, is it lagging? I'm sorry, I've got a little bit too much going on, don't I? What if that surface was just a square and it rose off the XY plane? What is the volume of a square prism? LWH, length times width times height. Okay, but what if it wasn't a rectangular prism? What if it was a right triangular prism? I don't know if I can draw that very well. If we got the base and the height, oops, guess we better call that altitude. So 1/2 base times the altitude times the height, right? This is the idea. And in fact, it could be a randomly shaped prism, whatever it is, a pentagonal prism or whatever. Yeah. What would the volume be? What did you do to get?
Just the area of the front base times the width or whatever.
The volume of a prism is the area of the base or the face, right? Times the height or the distance between those two bases, right? So if we are given these known cross sections lying between x equals a and x equals b, and that cross sections are perpendicular to the x-axis, here's our x-axis, whatever the figure is, the cross sections are perpendicular. I gotta tell me if it's not visible to the x-axis. What is the height of that one prism, whatever shape it is? D dx or delta x, right? It's a change. It's a change in x values. So it is actually an integral from a to b, because what we do, remember, areas, we summed up all of those infinite number of rectangles, right? It will be the same thing with this cross-sectional volume. We will sum up all the little areas of the faces times the height. It is straightforward. What is, now this might seem really silly, but go back. What's the area of a square? Side square. What's the area of a triangle? Height, we'll call it A for altitude, right? Because that would be a different height than the distance between the two faces. How about a semicircle? Pi r squared over 2 or 1/2 pi r squared, good. And rectangles? Length times width. Right. So what we're going to do now is we're going to look at these. I do want to show you, because my drawings, there's no way I can ever try to draw a cross-sectional volume. Here, ruler or no ruler, it is an impossibility. Here is one. We've got, see, it's sticking up off. I never made it, even in Calc 3. The drawing of 3D figures was not great. There's a couple more that they have drawn in here. I like this one especially. Because if I was thinking of an application for this, application for that type of figure is, maybe, obviously semicircles, yes, there could be.
For figure B, it would be a bow of a ship, I think.
The bow of a ship,
yeah.
That would work. I was thinking of like an axe the blade of an axe or
Well,
something.
look at how, even if it's a splitting action, I'll watch it out like now or.
Yeah. So, we have that square root of x again, and we have x equals 9. 4, 5, 6, 7, 8. 1, 2, 3, 2, 4, 6, 8. Here's 9, right? So we have this is the base of the solid. And cross sections perpendicular to the x-axis have the given shape. So I'm going to just do my normal little slice out of there, right? And it has a height between the two faces of d what? Dx. Here's what I do. I take that slice out, and then I lay it on its side, and I draw it here. This is the one representative slice. So that even if they come up with some randomly different figure, if I have my slice right there, I know that distance between the bases is a d what? Dx. And I also know the area of this square face is like side times side, right? Well, the only side I can get from this figure is this base, right? Because the base is lying on that figure, and it's sticking up off the page. Are you getting the picture? I can't draw it,
So
but
you take a slice of that area and you use that slice to do all those other
to sum up all of the, yeah. Oh, my batteries. Oh, I had it plugged in.
Uh-oh.
Did I forget to cut it on? All right. There we go. So what is the distance for this length right here?
Well,
This is the random point xy on my curve, right?
yes.
Which value?
The y value.
It is just the y value. Oh, but we're dealing with x's, so what is the y value? Square root of x. Oh my goodness, it's a square, so what is this length also? What is the area of this one face? X. Square root of x times square root of x is x. The height is dx. Sum up all of those little infinite number of square faces. What are we going to integrate from? 0 to 9. Honestly, cross-sectional volumes are easier. I don't know why students feel like it's harder every time. What is the antiderivative of x? 9 squared is minus some zeros. No dealing with big R's or little r's or anything, right?
Also, just to be clear, when it says quadrant, first quadrant bound by the graphs of y equals square root of x, that would mean that it's y equals square root of x in both directions, correct?
And no, y equals square root of x is defined to be a positive number.
Yes.
If I had x equals y squared, that's a different situation.
Yes, I understand that.
That would have been both the top and the bottom.
No, not both the top and the bottom, both the horizontal and the vertical. So it's both, it's the two, it's y equals square root of x in this direction and y equals square root of x in the horizontal direction. Because it's a 3D object, right?
No, the 3D object, this is just the base of the 3D object. The object is sticking up off the page in the form of squares.
Yes.
And so as we get down here, the square goes next to nothing. And then it gets bigger and bigger.
And so in both directions it's bound by the same equation, which is y equals x.
This is just the base. The top part, while they're still squares, see, this is a little better thought process. It doesn't, the base, well, I see what you're trying to say. Maybe the top does look, the top kind of might, yeah, the top would be bounded by it. Not on all sides. It would be just the top and the bottom, probably.
And so you have the base right here, and then the height would also be bounded by that exact same equation, which is y equals square root of x. Because it's the same shape in both the horizontal and the vertical.
I think you might be right. I've never thought of it that way, but I think you might be right.
And I drew a picture of that.
I simplify this as much as possible, and I literally just think of one of the squares.
See, so it's just the same.
I think you're right. All right. So guys, let's do a different shape. So now the base is still the same, but instead of being squares, it is a rectangle with a given height that stays a 3. So that one would not have the same boundaries of what you were saying, right?
No.
So I'm pulling out that thing, only the height doesn't change, right? This is still a square root of x for the base, right?
Yes,
But what's the height?
3.
3. So what is the area of this one face?
3 square root of x.
3 times square root of x. And turn it into a volume. Throw it in the dx. Integrate to sum up all of the volumes still from 0 to 9. And we're there.
So it starts off really small and then grows into the 3
Yeah, only this one,
Only goes in one direction.
it's still sticking up 3 units off the page right here at the point. It's weird. We could pull out the 3 and make
Right,
it
do it
x.
like where you have, this is the horizontal and that's the vertical. It's just the same
Yeah,
equation, but.
I got you. All right, so now, what are we gonna do? I pulled the 3 out because it's just a constant, right? Is this a hard integral?
No.
Not really.
Pi r squared.
Add 1 to the power,
Oh, wait, no, I'm not finding that, sorry.
divided by 3 houses, multiplying by 2 over 3. Oh, maybe I need that 3 in here so we can cancel it, right? The 3's cancel, right? 2, what is 9 to the 3 halves? Square root of 9 is 3. Cubed is 27. Times 2 would be 2. Unit squared. Oh, that's right. Your 5th grade teacher didn't count it off because you didn't put unit squared. All right. So pulling out that same thing and making it a semicircle, right?
Yes.
Yeah. Now, the issue here is we need the radius, don't we?
Right.
That whole length is what? It's the y value or square root of x. So what would the radius be then?
Square root of x over 2.
Yeah. That, and we still have a dx, right? So the area of that face would be pi square root of x over 2 squared, right?
Yes.
Times the thickness throws in the volume. Integrate. What is square root of x squared? Just x. 2 squared is 4. So while this was a little bit harder to think of the radius, it still isn't a terrible integral, is it?
No.
Add 1 to the power. Divide by the new power would make it 8. 9 squared is 81. 81 pi over 8 minus zeros. A quarter of a circle. What?
Alright, well, pi over 4. Pi r squared over 4. Let's go.
So I think a little bit more needs to be thought of though. Because if it is a quarter of a circle, I think it needs to be discussed. Is it just this?
Well, the radius would just be root x, wouldn't it? Or just-
Yeah. This is the only way I can think of having it sticking off the page. I think there needs to be a little bit more description, right? It's a quarter of a circle with, you know, the radius being the base. The radius being on the base or whatever.
Yeah.
And so both of those radiuses would be square root of x, right? And we still have the little, oh, it would be a 45, 45, 90. Look at you. But what's the area of this? A quarter of a circle. Pi.
1/4 pi r squared.
Yeah. Throw in the dx. We've turned it into a volume, right? So,
Then 0 to 9,
wait a minute.
take 1/4 pi out, so just be,
What did you get for semicircle? 81 pi, right?
This turns out to be the same answer as above.
That'd be pretty nifty.
no, actually, no, I see the problem. With the one above, you did divide everything by 2, you did divide pi by 2 and 1 above.
The,
Well, no,
the
other-
radius can just be divided by 2.
Well, no, but basically, with you
Oh.
have there is
Oh, pi r squared over 2.
There you go.
Nice call. Over 2 would make it over 16, wouldn't it?
Yes, ma'am.
Nice call. This one will just be x squared over 2. Yeah, this will be exactly what we came up before. Oh, 81 over 8, right? Equilateral triangles. This is the one that we've got to pull our little slice out, and then we got to do some pre-calc on it, don't we?
Yeah.
What do we know about equilateral triangles? Each side is the same. In this case, the y value or square root of x, right?
Yep.
But how in the world, so I've got the base, right? For the 1/2 base times height. How in the world are we going to drop down that height and figure out what it is?
30, 60, 90.
Oh my goodness, 30, 60, 90.
Oh,
The short leg is
pre-calc.
half the hypotenuse, right? What's the long leg? The short leg is square root of x over 2. So multiply that by root 3, right? If you can read my writing. So this one area is 1/2 base times height
What's the
Hypotenuse is just root x.
is root x.
So it's equilateral.
Oh,
Yeah, because it's equilateral, right? The short leg would have to be root x over 2, right?
Yes.
The long leg or the altitude would be root
X over 2 times
square root of x over 2 times root 3. So there we go. Throw in the dx. We've got the one volume. Can we clean this up?
Yes.
What's 1/2 times 1/2
1/4.
times square root of 3?
X. So just be x root 3 over 4.
Why'd I put a 3? Still integrating 0 to 9? Well, looky there. Guys, look at part A. Do we already know what this is?
81 over 2.
81 over 2 times root 3 over 4. 81 root 3 over 8 is what I see. Our time is pretty good, I guess.
No, we're doing okay.
Still doing all right. All right. Got a little bit different. Now we're not just dealing with the x-axis as part of the
Alright.
We have, all right, well, at least one of them's a line. Y equals x plus 1, y equals x squared minus 1. Anybody know where these cross? Certainly looks like it crosses at -1. How do we find where they cross?
That was a good way to y equals x plus 1, and
You don't even have to do a system. How do we find the x values where they cross?
equal to other.
Set them equal to each other.
Oh, duh.
We just did that in the 7-1 section, right? So we got 0 equals x squared minus x minus 2, agreed?
Yep.
What does that factor into?
X minus one, or
Plus 1 and,
X plus 1, x minus.
alright. And that would have x equals -1 and +2. So it looks pretty good, you know. And I'll tell you, sometimes on the AP exam, they'll even be kind and give you the intersection points. Sometimes not. So this is the area of the base, right? In fact, remember how I started that, the last class with a free response on the AP? Like part A might be, find the area between these two curves, right? What would that be?
Okay.
Top minus bottom, right? Integrate from
0.
-1 to 2, right? Then you might have another one that says revolve this about some line. It will probably be a horizontal line in this case.
What if you were to revolve that around, let's say, y equals 0, x equals 0?
Oh, yeah, I never have a rotation about a line that's right in the middle of it, because that gets really, really,
Well, because then you're.
I don't even know how you would do it
You're lapping the
accurately.
volume of it, so.
Yeah,
Would-
you'd
would
probably
lapping
have to
it
do
make it
little
have-
bitty pieces
Well, no,
of
yeah, I was
it.
gonna say, you'd have to slice it across the.
You'd
would
have to do little,
lapping them create negative space, or would it just double it?
it would just double it, so you'd have to break it apart, I think. But, yeah, so we could do it like about -1, or y equals -1, you know, or something, but
We'll just make the four-dimensional cube, it'll work.
I'm not gonna turn this in, because we still have a couple more. All right, so cross sections perpendicular to the x-axis are squares. So we're dealing with a d what?
DX.
Dx again, right? Pull that square out. Y'all think you're ready to take off on this one?
I think so.
We can try.
Miles, no.
What's the width
You can try.
or the height, the distance between the two faces?
DX.
What is this bottom and the side going to be?
X plus 1 minus x squared minus 1.
X plus 1 minus parentheses x squared minus 1. I like it. And because it's a square, this is exactly the same thing. Can we go ahead and distribute? X minus x squared plus 2.
Yeah.
All right. So this one might be slightly weirder because we do have to square a trinomial, right? What are our limits of integration?
Negative
Panel.
1
Panel.
Negative
-1
1 and 2,
to 2. How'd you get that?
because that's the horizontal limits.
Those are the x values. Like this would be the point -1, 0, right? 2 comma something. 3. 4 minus 1 is 3. So, can I leave the algebra for you on this one?
Yeah.
Okay. Rectangles with height 2. That base is still x minus x squared plus 2, and the distance between the faces is still dx, right?
Yes.
What is the height?
2.
Always 2. So this one will be much easier, won't it? We're still going to integrate from -1 to 2. 2 times all that, right? Or we could have pulled the 2 out, either way, right? But I thought of taking it in for this one reason. Add 1 to the power here, you get
Oh.
squared over 2. Cancels, right? 2x cubed over 3 plus antiderivative 4.
4.
Good. What are we plugging in first?
2.
2. Squared would be 2 cubed is 8 times 2. 4 times 2. Oh, we get one that we don't subtract all zeros, right?
No.
1, -1 cubed is negative times a negative plus 2/3 minus 4.
Lovely.
I still have to do my algebra 1 part 1 step. I still have to distribute all my signs, right?
Yes, ma'am.
4 plus 8 is 12
Wait, the four's cancel.
minus,
Four's cancel. No, oh,
no, it became a positive.
Okay.
12, 13, 14, 16 minus 1 is
15.
15. Negative 16/3 minus 2/3 is negative 18/3. Minus 6. Well, looky there. Wait, 15 minus 6 is 9. You made
Oh.
a Janet Washington mistake. All right. I mean, we all do. Rectangles whose height is twice the base.
Oh.
I'm going to let you set up but not evaluate this one.
Okay,
Oh,
do that.
thank you.
Oh, we don't have to evaluate it?
The height is twice the base, so if I pull out the base, we got to go up higher, right?
Yeah.
So just be
X minus x squared plus 2 dx. What is this height then going to be?
2x minus 2x squared plus 4.
And then our formula,
Is
integral from -1 to 2. Yeah. Set up but do not evaluate. I mean, all right, if we hadn't have distributed, we could have just had this thing times 2, couldn't we?
exactly.
Yeah. And if we had done all of the algebra up here, just take your answer and multiply by 2, right? Because that 2 could have been factored out, right?
Yeah, that wouldn't have been
I know. Semicircles and equilateral triangles. Again, set up but do not evaluate. Or maybe it could be on a calculator page or something.
Yeah.
But the setup is absolutely the most important, calculator page or not, right? What is the radius?
X minus x squared over plus 2 over 2.
Yeah, or 1/2 x minus x squared plus 2, right? 1/2 pi r squared. Maybe I won't make that same mistake. Dx, throw in the integral. Does that make sense?
Yep, and then 0 to 1.
-1 to
-1
2.
to 2,
1/2 squared is 1/4 times 1/2. Does everybody see that would be pi over 8? And again, if you had done part A, you would have just taken your answer and multiplied by pi over 8. Does that make sense? Again, if I am doing it, or if it's on the free response, literally don't do any algebra. Just do the setup. And be careful with parentheses. You could leave,
Keep the 1/2 in there and not square it.
yes, keep the 1/2 in there. Don't square it. Use parentheses where they, or brackets where they need to be. Does that make sense? And then we've got the equilateral triangles. We've talked about it. That height is just half of the base, right? Times root 3.
Root 3 over 2 times.
So we've got 1/2. The base is that same x minus x squared plus 2.
Wait, so couldn't you take root 3 over 3, it's going to be root 3 over 2, negative 1 to 2 times, and then within the integral would be x minus x squared.
1/2 base. The height was root 3 over 2.
Correct.
So another root 3 over 2 squared dx. Everybody following what we're skipping all those steps?
And then x minus...
It's really root 3 over 4,
Oh, yeah.
right?
How do you know the height is root three?
Because the base is still... The base doesn't...
Remember this base, let's call it y. It's not really y. It's y2 minus y1, right? But let's just call it z. The short leg would be half of z, right?
Yeah.
The long leg, the height, the altitude is z over 2 times the square root of 3, right?
Right.
So what we did was we took that thing over 2 times the square root of 3 and multiplied it by the one that we already had, the base,
Right, you don't
right?
multiply 1/2 twice, though.
Yes, you do. An area of a triangle is 1/2 base times height.
Correct? Oh. That's good. Okay.
The height is 1/2
Alright.
of, yeah,
That's good. Okay.
yeah.
Squared, then alright.
Again, if we had already done problem 1, this would be super easy, wouldn't it? Or problem A, I should say. Here it is, AP 2009. Take off. Everybody do part A. Let's see what we got. I like the regular ones, I just don't like that. Get to work.
How do you eat cheese?
What?
Look at America.
I got it.
Honestly, imagine you doing like some
Do
spicy.
problem A.
How do you eat cheese? I would die if I couldn't eat cheese. I agree with you. Cheese is overrated. Like crassy. You want a snickerdoodle to watch?
I want you to do problem A,
And a snickerdoodle?
part A.
Why is it spicy?
There's no pies in part A, it's just the area, right? Don't make it hard.
Well, what if it was pie day and what, like a...
Look how nice they were. They gave you the intersection point, right? The area, go back to 7-1, right? That is just, what's the thought for area? Top minus bottom. No rotations. No, yeah. And we're gonna do top minus bottom. Gosh, that doesn't even look vertical. We're going to do top minus bottom because this is wise in terms of x's and it makes it easier, doesn't it? So now, Miles, what you got?
I think it's 4/3, I don't know if it's,
The integral from
0 to 2.
2 is the x value. What's the top one? Minus bottom. Everybody following that? So this would probably be worth, it could even be 2 points. One for the limits of integration, or 3 points. One for the limits of integration, one for the other, and then one for the answer. So you gotta find the antiderivative. Would be x squared. X cubed over 3. What do we got when we plug in the top? Minus the zeros. Pre-response it. Be happy. 12 minus 8 is 4. All right.
You would go as far as plugging, you know, go as far as plugging.
You have to go through plugging. Yeah. All right, now the region R is the base of a solid. For this solid at each x, the cross sections perpendicular to the x-axis have an area sine of pi over 2x. See, this is what, yeah, they love to throw in some randomized thing. But the randomized thing is the area of the face. I don't know what it looks like, but I don't care, right? Because the thought process is multiply the area of the face times the what? Thickness, which is what? It's the thickness is the dx, right? Or the height between the two faces. And they're still perpendicular to the x-axis, right? What do we integrate from? 0 to 2. So while it is an AP curve that they love to throw in there, right? A curveball. It actually turns out to be, at least the setup is easier, right?
Yes.
How do we integrate with the sign of a blob?
Okay, well, the derivative of blob is,
We must have the derivative of the blob, pi over 2. Therefore, everybody with me there?
pi.
Aiden, you've been quiet. You with me there?
Yeah, I think so.
What is the antiderivative of sine blob? D blob, that's checked off in there and ignored. What'd you say, Martin? Is it regular cosine or derivative of sine is regular cosine? The, so we need to have a negative cosine, don't we? Of the same blob. Can we stop there on free response? No. Wait, did I put a negative here and a negative there?
Silly goose.
Silly goose. So on the cheating way to do the, free response, 2 would just be pi minus, I took that negative out, so I'm leaving the cosine alone. And they would allow this. But this could easily be a multiple choice question. You cannot get out of knowing your trig, correct?
Correct.
What is the cosine of pi? Cosine of 0 is 1, correct? Cosine of pi is -1. So, -2 over pi, -1, minus cosine of 0 is what? +1. So I'm looking at -2 times -2 over pi would be 4. I was thinking 0 myself when I was looking through that. All right. All right, look what they did in 2009. Another solid, and by the way, we haven't practiced any solids that are perpendicular to the y-axis, have we?
No, we have not.
What would that height be? D what?
dy.
dy. Our squares, well, looky there, they were nice to us. They made them squares. So we got our dy. So what is this distance, this length of the base?
That would be y, so
Right minus left. Look at you. The right x value,
the square root.
the x value is going to be square root of y, isn't it?
Y
Yeah.
minus
And the
y
x
over
here would be y over 2. So is that square root of y minus y over 2?
Yes.
And then we're just going to have the same thing, because it's a square. So square that thing. dy, integrate from,
0 to 4.
look at you, 0 to 4, because we are dealing with
Y.
y's, not x's, right? So, can we square that out? Right, but do not evaluate. Well, looky there. Look at me, almost doing too much because I didn't read. Right, but do not evaluate.
Would they take that?